Hello, everyone. My name is Dean Biscocho. I would like to start by thanking Jeannie, Bractlet, and Codesmith for sponsoring this Tech Talk. And to the audience, well, you are software engineers and could be anywhere else in the world, but you're here with me. And for that, I thank you. Let's jump in. So I'd like to take you on a journey that I've titled Back to the Future of Cloud Tech. Now, in this talk, you and I are doing some time travel. Why? Well, to explore 3 points in our timeline as engineers. What was life like before the cloud? What was life like immediately after its release? And how is life better today with cloud tech? Let's begin. The year is 2005. Some 20 years ago, we were hopelessly shackled by the limited functionality of our local servers. AI was not a practical technology. It wasn't. AI was Allen Iverson. AI was a Spielberg movie. Now, you might not remember this time vividly, but I do. So come along with me. Picture this. It's 2005. AWS is nowhere to be found, and you are a software engineer in the before time. Tuesday morning, you wake up, have breakfast, commute, park your car, sit at your desk, and wiggle the mouse of your desktop computer, an Intel Pentium 4. You're reading an email when your coworker stops by. Hey, conference room in 5 minutes. Now, for context, your company is a multinational consumer goods company with a significant IT department, and you are a core member of it. Now, in the conference room, you pull up a chair. Your whole engineering team is there, but you're surprised to see some other familiar faces you rarely see. Money people. We're talking finance staff. What the heck are they doing here? On cue, a finance officer addresses the room. They say, there's good news and there's bad news. The good news, well, we've been making an absolute killing. And the bad news, due to increased demand, the existing server infrastructure is kaput. We've got performance issues and delays processing the transactions. We're leaving money on the table. And it's at this point, it dawns on you. You are the engineering lead for infrastructure. That means you have to talk now, and they have to like your answer. So your mouth opens, and the following words spill out. Servers. I guess we need new servers. And they ask, how many? And you say, it depends. We would need to determine the specific requirements, processing power, memory, storage. Once we have the specs, we would buy the servers. And they ask, does that solve the whole losing money issue with the sudden spikes in traffic? And time pauses. You're smart. You realize what's unfolding before you. Your chill IT gig is about to kick your teeth in. And in the time it takes for every eye in the room to point back at you, your engineering brain sees it, the mountain of work that lays ahead. Let's take a closer look at what you're thinking. You need more staff. You need more help. Why? To help you with manual labor. Software engineers would be responsible for procuring and setting up physical servers, networking equipment, and storage systems. This process involves tasks such as hardware installation, configuration, cabling, power management, and cooling. Additionally, engineers would need to perform routine maintenance, including firmware updates, hardware repairs, and just generally troubleshooting issues. Your team would also need to predict future capacity requirements and provision hardware accordingly. Scaling up or down would require manual intervention involving the purchase, installation, and configuration of additional hardware. And during a down period, you'd have to manually decommission underused resources. Let's talk data backup and disaster recovery. Engineers would have to handle this manually. This means scheduling regular backups, managing storage media, and setting up off-site storage and backup facilities. In the event of a disaster or hardware failure, engineers would need to restore the system and data manually, which can be time-consuming and error-prone. And so, we return back to our scene. The finance officer asks again, does that solve the whole traffic spike thing? Sweat building on your brow, you nod your head, yes. The room senses your sudden and pronounced deflation. The group relents with no further questions. So that is life before AWS. Let's move forward now, a little bit in time. It's 2008. AWS is a newer technology, just waiting for your company to adopt it. And in this case, you are a different software engineer at a different company, but today you have Cloudtech. Now, imagine this. You're at your desk watching YouTube. It's a game review of GTA 4. Coworker stops by, says, meeting in the conference room, 5 minutes. For context, your company is a cool one. It used to be a DVD rental service and is now leveraging Cloudtech, potentially, to change the way people consume movies and TV. So you pull up a chair. Oh, it's our old friend, the finance officer, here to address the room. Says, good news and bad news. Good news, we're absolutely killing it. Bad news, our servers can't keep up with the demand. It's difficult to predict and handle the spikes in traffic, especially during peak hours or new releases. And it's risky to depend on a single or few locations for the service, as any outage could affect millions of users. We pause here. We realize something in the universe has prepared us for this exact moment. We have AWS now. So we immediately speak up. What about cloud computing? Cloud computing is a service that provides on-demand access to computing resources such as servers, storage, databases, and networks over the internet. By using cloud computing, we could benefit from several advantages. First, it could reduce costs and complexity by outsourcing our infrastructure and management to a cloud provider, such as Amazon Web Services. Secondly, we could scale up or down our resources according to the demand and traffic without worrying about capacity or performance. And third, we could increase our reliability and availability by distributing our content across multiple regions and zones, minimizing the impact of any outage or failure. There's a quiet in the room. Then one person claps, then another. Then someone stands up, then another. You're receiving the first standing ovation in that building. End scene. Much better result, no? So let's fast forward to today, 2023. We still have AWS. Now, you're a modern software engineer and you work from home. Your company is a rapidly growing e-commerce platform, and you wake up, roll out of bed, pour a cup of cold brew, and join morning stand-ups. So you're an engineer, your lead starts by saying, hey team, we got a new engineer today, not you. I need someone to walk them through AWS services, get them up to speed. You think to yourself, well, we have materials prepped for that, onboarding materials. And you speak up and say, I got it. So stand-up ends, everyone else leaves, while you and the new recruit hang back to start training. And you share screen and play the following training video for the new recruit. Hello, new team member. Welcome to the FlexDrip team, the best online source for drip. As our platform gains popularity and experiences increased traffic during our peak shopping seasons, the scalability and elasticity offered by cloud technology becomes absolutely crucial. You're going to want to familiarize yourself with our favorite offerings from AWS. In this case, EC2, the Elastic Compute Cloud. To help get you up to speed, let me provide you with a helpful analogy. Now, imagine you're the owner of a retail store that is rapidly growing in popularity. On regular days, you have a steady flow of customers and your store comfortably accommodates them. However, during special sales, you expect a massive influx of customers and your store needs to be prepared to handle the sudden surge. In this analogy, your store's physical space represents the computing capacity of your e-commerce platform. Customers entering your store represent website visitors to your e-commerce platform. The store's staff members represent the computing power provided by Amazon EC2. Now, let's see how you would utilize Amazon EC2 in this scenario. On regular days, you have a sufficient number of staff members. That's EC2 instances to handle the steady flow of customers, website visitors. During a special sales event or holiday, you anticipate a significant increase in customer footfall. That's website traffic. To handle the sudden surge in customers, you leverage the scalability and flexibility of Amazon EC2. Just like you would hire additional staff members to accommodate the increased customer load, you need to provision and launch additional EC2 instances to handle the increased website traffic. These additional EC2 instances act as extra computing power, allowing FlexStrip to handle the sudden spike in traffic effectively. Elastic load balancing ensures that customer traffic is evenly distributed across multiple EC2 instances, preventing any single instance from becoming overwhelmed. That'd be bad. And since we're on the topic, let's talk about load balancers. Think of a load balancer as a traffic cop at a busy intersection. Imagine there are multiple roads leading to different destinations, and each road represents a server or resource in a computer network. When cars, these are client requests, approach the intersection, the traffic cop, our load balancer, assesses the traffic situation and determines the most optimal route for each car. The cop considers factors like road congestion, the capacity of each road, and the overall load on the system. Instead of sending all the cars down a single road which may become congested, the traffic cop distributes the cars across different roads. This way, the traffic load is balanced and no single road is overloaded. Now back to our original analogy. Auto-scaling automatically adjusts the number of EC2 instances based on predefined scaling policies, ensuring that you always have the necessary capacity to handle the increased customer load. And once the sales event subsides and the customer footfall returns to normal, you can scale down the number of EC2 instances to optimize costs. By leveraging Amazon EC2 in this way, our FlexStrip team can dynamically and efficiently handle the sudden and significant spikes in website traffic, ensuring a seamless shopping experience for our customers. And that's it from me. Thanks for joining the FlexStrip team, and good luck out there. Yes, and that's it for me as well. We return now to current day. Here are my sources, and I hope that you go forward with a greater confidence in what Cloudtech can offer you as engineers. And if you're hurting for more on Cloudtech, feel free to reach out to me on these platforms, GitHub and LinkedIn. I'll yield my time now to all of you.